At the 1.5 worksheet, first page here, a couple application problems. To me, these are kind of the nuts and bolts of what we've been learning in this unit. So on the first one here, it says, suppose you borrow $30,000 to buy a new car. The bank charges you interest at an annual rate of 2.9% compounded monthly. Your monthly payment on the loan is to be $600. So the first thing we need to do is write a recursive rule that's going to calculate out the balance of the loan each and every month, something that we definitely would have to figure out and want to keep track of if we bought a car. So we start with U sub 0. How much did we borrow? We borrowed $30,000. So it's going to start as a $30,000 loan. How do we try to decrease this loan? And what's happening to it is the recursive part. So we have U sub n minus 1. So we're going to take $30,000 and the bank's going to charge us 2.9% interest, but it's compounded monthly. So we're going to have this 1 plus, change the interest rate to a decimal, so move it over 2 spots, 0.029. It's being divided by 12 since it's monthly. And now we got the interest added. So our account actually gets bigger. However, we get to subtract $600 because we're making a $600 monthly payment. So now, the next question says, what term of the sequence will show the balance of the loan after 12 months, and what will that balance be? Well, what term of the sequence? Well, that will be U sub 12 because we started at U sub 0. U sub 1 would be after 1 month, so we're looking for the U sub 12 term. So to get this particular value, this is where the calculator is going to come into play. So we're going to go to our y equals, and we're going to type in our recursive piece. So we're going to do this times, then I'm going to kind of delete this part so I can type it all in at once so I know I get it right. So it's times parentheses 1 plus 0.029 divided by 12, close parentheses, subtract 600. So what's nice is we can do these, again, these shifted geometrics. Now, our starting value wasn't 12,000, it was 30,000. Now, before I go to my table, I'm going to go to table set because it might be a huge number. I want to start at 12 here. Notice how it was at 216. So then I can go to my table and I can see what my car balance, what I still owe on the car after 1 year. So I still owe $23,585.18. Now, the next part is, how many months does it take to pay off your car loan in its entirety? Well, if there was no interest, if I were to take $30,000 and divide it by 600, I'm going to just kind of do this by hand here. Cross out my zeros, 300 divided by 6. Well, 6 goes into 35 times. I know that I would have to make at least 50 payments. So I'm going to start at 50 payments and continue on to see how many it's going to. So I'm going to go back to my calculator. I'm going to go to my table set, and I'm going to change this value to 50. So I know it's going to take a minimum of 50. Now I'm going to go to my table. And this does take a second or two to load up. So now, again, remember, this number tells me how much I still owe on the car. So as I keep on going, a lot of students will stop right here and say, well, it takes 53 because, that last payment. I've actually made 53 payments and I still owe $211.43. So it actually takes, you go to the first negative, 54 months. So this is one of the key pieces here. So it actually takes 54 months to pay off. Now over here, I'm just going to note what the calculator said on those last terms. At 53, it was 211.43, and at 54, it was negative 388.05. Because this helps you when determining how much you actually paid for the car. So when we're trying to figure out how much I actually paid for the car, I was paying $600. I did that for 54 months. But on the 54 month, this is how much you overpaid by on that last month. Okay? So that's how much you overpaid. So I need to subtract 388.05 from that. So if I type that into my calculator, it should equal $32,011.95. So my $30,000 car actually cost me $32,011.95. So you gotta think about that when you're buying a car and you're borrowing money. You're actually, when you gotta pay interest on it, it costs a lot more. All right, number 2. This one I think is a credit card one. Suppose you have $15,000 of debt on your credit card. The credit card company charges you an interest at an annual rate of 14.9% compounded monthly. That's a typical rate. Sometimes they're higher or sometimes lower. You decide not to charge anything more because you got to pay this credit card off, and you plan to make $500 payments on the card until it's paid for. So again, we're writing the recursive rule here. So u sub 0, that's our start, $15,000. Our u sub n equals u sub n minus 1. How are we paying this off? Well, unfortunately, we have to pay interest. So we take that interest rate, so we're going to go 1 plus 0.149, and we're going to divide it by 12 since they're charging it monthly interest. So they're going to tack on that interest first, and then they're going to subtract your $500 payment. So now we have our recursive rule. B asks, how many months does it take to, or what term of the sequence will show the balance after 2 years? So now this says after 2 years. So u sub, we're looking for u sub 24. So I'm looking for that particular value. So to get that, that's where my calculator is going to come into play yet again. So I'm going to go back to my, y equals, type in this new recursive definition. So now, sometimes I go a little bit fast here, but I want to change this to 1 plus 0.149. I want to make sure it's being divided by 12. Whoops. And then I need to subtract the right amount. See, I'm getting ahead of myself. Slow down, Mr. Parks. Probably thinking the same thing. Subtract not 600, but 500. That's why a lot of times I like to just delete it out and retype it. So now here, we were only borrowing not 30,000, but only 15,000. So, go ahead and hit enter there. And now I'm going to go to my table set. I'm not going to start at 50. It'll take a little while. I'm going to start at 24 since I want to see what my balance is after 24 months. So we go, take a look at it. Wow, I still owe $6,290.16. Wow, still don't have it paid off yet after 2 years. All right, so as I continue on here, question C asks how many months does it take? So I'm going to kind of do that same thought process. I started with 15,000, I was paying 500. If I divide those, 15 goes into, or 5 goes into 15 3 times, add the 0. So that I know it's going to be at least a minimum of 30, but I have all that interest that I have to pay. So when I go to my calculator, here's the nice thing is it's already sitting here at 30. So what I'm going to do is keep on scrolling down a little bit until I see, wow, look at that, it takes a little while, but I finally get there at 38 months. Now in part D, it's missing here. I think it got, let me go to the next page just for a second. Here it is. Usually I do it on the next page, but I'm just going to do it here, flip to the next page. I I'm guessing your worksheet is edited appropriately. So if I look again from my calculator, month 37, month 38, and it had 377.70 and negative 117.61. So I actually paid, $500. I paid it for 38 months. And then but on that 38th month, I actually overpaid by $117.61. So for my $15,000 credit card bill, I had to pay them $18,882.39. Hence why credit card companies make lots of money. And this ends that page.